Okay, this is Chapter 7, Lesson 2, Complementary and Supplementary Angles. I know I said at the end of last lesson, I'm going to start off at the beginning of this lesson saying it. Guys, there's so much vocab in this chapter. You should be making flashcards. So it's not too late. You've got Chapter 7, Lesson 0, Chapter 7, Lesson 1, and now Chapter 7, Lesson 2. If you haven't started making flashcards, make them now because there's a lot of vocab for this test, and flashcards are the best way to study. Okay, let's get started. Complementary and supplementary angles. Complementary angles add to 90 degrees. So there are two angles or three angles or even four angles, but all together they add to 90 degrees. They form a right angle. Typically, by the way, we'll be talking about two angles here when we talk about complementary angles. Okay, so they add up to 90 degrees, they form a right angle. Let's draw two examples of complementary angles. Here's one where we start off with a right angle and then it is split into two smaller angles. So this angle here, angle 1 and angle 2 would be complementary because when you add them up, when you put them together, the outside edge forms a right angle. Okay? Here's another example of right angles. I could have just two kind of random floating angles in outer space. This one could be 40 degrees. And this one over here could be 50 degrees. They don't have to be touching to be complementary. They just have to add up to 90 degrees. Okay, for our purposes, this is the diagram I want you to be really familiar with. I want you to be really looking for this right angle and have it split into two smaller angles. That's big for us. Okay, supplementary angles, very similar to complementary. They're two or more angles that add to 180 degrees. So the difference here is that they're not 90, they're 180 when you add them up, and that means that they form a straight angle. This is also extremely important for this chapter. Typically, it's going to be two angles, not 3 or 4 or 5. Okay, let's get two drawings. First one, 180 degrees, that's a straight angle or a straight line, right? So we'd start off with a straight angle and now we have a ray that splits that straight angle into two smaller angles. In this case, it's an obtuse angle and an acute angle. We'll call this angle 3 and this angle 4. And since they are put together to form a straight angle, then we would call them a pair of supplementary angles. Okay, another example, again, they could be floating in midair. That's fine. Maybe I've got a 90-degree angle here and a 90-degree angle here. They don't have to be touching to be supplementary. They just have to add to 180. Okay, so let's do some examples. Name a pair of supplementary angles. Well, guys, supplementary means straight angle. So the first thing I want to do, it means two angles that form a straight angle. So I start by working backwards. I find myself a straight angle, and then I look for a ray that breaks that straight angle into two smaller angles, and the two angles inside are my supplementary pair. So I work backwards a little bit. I start with a straight angle. I find a ray that splits it into two smaller angles. Here's one, there's one, and they are supplementary. So my pair of supplementary angles are angle FCG, FCG, and angle GCH. Angle GCH. Together, if we put those two angles together, that outer edge is a straight angle. That's why they are supplementary. Okay, let's do number 2 here. Name a pair of complementary angles. So for supplementary angles, I started off by looking for a straight angle. For complementary angles, I start off looking for a right angle. So here is a right angle. And there is a ray that comes in the middle and splits that angle into two smaller angles. So this angle here and this angle here are complementary because when you put them together, the outside edge is a right angle. So my pair of complementary angles are angle GCH, angle GCH, and angle DCH, angle DCH. Okay, so again, I work backwards here. Working backwards is the key to finding complementary and supplementary angles. For supplementary, look for a straight angle. For complementary, look for a right angle, and then see the ray that splits them into smaller pieces. Name a pair of vertical angles. This is a flashback to Chapter 7, Lesson 1. Vertical angles, remember we want to look for an X. That's the key to finding vertical angles. So I see a line here. Maybe I can do a better job tracing that line. I see a line here. That's better. And a line here. And they intersect, forming an X. Okay, so my X is there. And then vertical angles sit across from each other. So I'm going to focus on this angle and this angle right here. Okay, so angle GCH and angle FCE. I want you to remember something. I'm just giving you one example for each of these. For most of these, or at least for numbers 1 and 3, there are many pairs of supplementary angles. For number 3, there's 2 pairs of vertical angles we could have talked about. In this diagram, though, there's only 1 pair of complementary angles. So I do challenge you to find more pairs of supplementary angles and find at least 1 more pair of vertical angles. I think that's all you can do here. But try that out, see what you're looking at. Make sure you understand where things are going here. Okay, last one for us, solve for the missing variable. Well, I'm telling you guys, these look really interesting, these 2 angles. I think if we'd put this angle and this angle together, we would end up with a right angle. Too bad I can't move them around. That'd be cool to be able to show you that. But if I would push those 2 angles together, we would get a very, very, very 90-degree right angle. It would look like this, with the 7r plus 6 here and the 8r plus 9 here. So this is going to look like a little bit different equation than the last one we did in 7.1. These 2 angles are adding together. They're complementary. So they're adding together and they're going to equal 90. That's what complementary means, right? They add together, they equal 90. So we are going to write an equation, and we are going to solve that equation. And the equation is adding these 2 values together, and it equals 90 degrees. So 7r plus 6 plus 8r plus 9. Okay, remember we can drop the first set of parentheses because there's nothing in front of it. For the second set of parentheses, we're going to distribute the 1 before we can drop them. 1 times 8r is a positive 8r. 1 times 9 is positive 9. So if we're doing this correctly, we're going to think back to chapter 6 and how we had to do it then. So like terms, 7r plus 8r is 15r. 6 is a constant, 9 is a constant, so they are like terms. Add them up and you get a 15 there as well. And they equal 90 degrees. And we can drop our train tracks into place to solve. Variable side, constant side. Which term doesn't belong on the variable side? It's the plus 15. So to get rid of that plus 15, we are going to do the inverse, which is to subtract 15. And we're going to balance that out on the constant side as well. We get 15r equals 75. And we're going to solve by dividing both sides by 15. And we get r equals 5 degrees. Now, this question could look a little different as well. They could ask us to take that r and substitute into each of these expressions to tell what each angle equals. So really quickly, we're going to do that mentally. 7 times 5, substituting 5 in for r, 7 times 5 is 35, plus 6 is 41 degrees. 8 times 5 is 40, plus 9 equals 49 degrees. And if we add them together, we get 90 degrees. Okay, So that was pretty cool. Another nice thing for us to do. So look for this question in a couple different ways. Maybe they're asking what's the value of r, maybe they're asking what's the value of each angle. Either way, you can definitely solve this. And I am going to tell you one of them in your homework tonight is kind of like this, but it's supplementary angles. So it'll add to 180 instead of adding to 90. So look for that one when you do your practice problems. Okay, ask any questions tomorrow in class. Don't forget to do your practice problems and make your note cards.